approach to make these in a GLP, GMP compatible process so that FDA actually accepts the kind of stuff that we do. We had to really dig a lot of things into investors and being able to really see what the different investors are excited about, who are the people in this space that are thing. And really, I think it's really important to kind of, you only have 1 or 2 shots on goal. So it's really important to go and pick the right thing to go after that gets investors excited, is an important problem, and is something that you can actually accomplish. So these were some things. You know, what I can tell you about my own personal lessons is through all of this is the size of the market is very important, how well differentiated your technology is. This team, and particularly a superb CEO, is essential. And really a superb CEO can pivot, because what you start off with in your own head about what the idea is probably not what the company winds up doing. So it's important to really pick the right person who can understand opportunities and be able to pivot into the right areas. And of course, you need to be able to be ready to fail, and all of this takes a lot of risk that you have to take on. So so this is some general things, and I just want to maybe just for time's sake, I will just kind of tell you guys that we're trying to now institutionalize this process at the Institute, because I think that's one of the things that's very different in academia. It's difficult to get such things institutionalized. So at the Institute, what I'm trying to do is to try to create a pipeline where this process that I had to go through over a multi-year process and do a lot of learning through and development to understand it can actually be embedded into the fabric of the institution. So what we're trying to do is create a process in which we only work on transformative ideas. We have a huge vetting process that, you know, through which a lot of ideas come in, and only few of them are selected for us to work on. And this ideas should address very important problems, and the Institute will start to work with investigators to de-risk the problems and cultivate them so that they can become viable startups. And you know, really working on this calculated risks. If we're going to do big risks, let's make quick decisions, fail fast, move forward, and create a culture that values this industry academic partnership and allows us to really build things and focus on this translation. And also the culture, the type of people that are there are just as important. So being able to have the right scientists who value these kinds of work and be able to work with the best people in trying to make it happen. So that's really what the Terasaki Institute is now trying to enable. So hopefully we'll have this flywheel through which we can put a lot of different ingredients with great people and great ideas and come up with intellectual property and startups that are going to be world-changing, and also along the way be able to train a lot of great people. So if you are ever in Los Angeles or ever interested in joining us, please let me know. And this is again, we're very interested in a full speed ahead model, and this is actually one of the outside of one of our first buildings, and it's very nice area in Los Angeles in Westwood. Definitely come and visit us. And this building is actually won a lot of architectural design competitions. It goes in a couple of floors as well. So, so definitely, I think this is what I wanted to kind of talk about most of the time. It's entrepreneurship is definitely something that is exciting, very time consuming, and there's a number of failures which I didn't talk about before as well, but it's a lot of learning process. So with that said, yeah, Mohsen and Houman, yeah, love to answer any questions.
Well, wonderful talk, Ali, as always, very informative and educational. I loved your talk and I learned a lot. As you know, we are also, we have started a company on one of the technologies that we developed in my lab, and then we are going through this process as well. And then I saw that our CEO, who is again, he is an excellent a boss for us, is also among the attendees. So we learned a lot from you. So we will start. So if you have any questions, please you can raise your hand. We will start with those who have raised their hands. What I'm going to do is I'm going to unmute you one by one, and you can introduce yourself if you want, and then you can ask your questions. Please make sure that your questions are short. If you have multiple questions, then we can continue the discussion. We kind of want to have a kind of like a panel kind of discussion, more interactive session, so we can hear Ali's thoughts on your questions, and then and also your. So we will start with the first question first. So Atta, I unmuted you. Can you talk, Atta? Atta Ullah?
Please introduce yourself and your organization as well.
Atta, can you talk? All right. So let's go with Ashwini. So Ashwini Kumar, and I unmuted you. Can you talk now?
Hello, am I audible, sir?
Yes, we can hear you.
Yeah, thank you. That was a great talk. So my question is, since you developed a composite of gelatin and nanoclay for the embolization procedure, what was the degradation profile of this nanocomposite after the fibrosis of the site?
Yeah, so basically within a month, you get rid of about 90% of the material. So a lot of it is degraded, but it's degraded not just by itself, it's typically degraded by infiltration of cells. So that's really the mode of the degradation most of the time. So as cells come in, they kind of chew away some of these material, and then they deposit their own matrix. So that's kind of, and that's degradation time is kind of consistent with some of the things that we wanted with the cell infiltration and fibrotic tissue formation. So in that sense, it's ideal, and also with regulatory process, because as you start getting longer and longer degradation time, you really need to perform these experiments a lot longer and show that the material is not going to have long-term effects. So for us, that 1 month for majority of the material was desirable.
Right. Can I ask an extension of the question?
Sure.
Sir, so if that degradation depends on the infiltration of the cells, so that might also depend on the site of the procedure, because there might be different immune cells and non-immune cells at different sites. So that degradation might also change based on the site. Is it true?
I think that's true, and I think that's to some degree for us. Most of the sites that we're putting are going to be inside the blood vessel, so it will be somewhat similar. But if you're putting in something direct injection into subcutaneous tissue or some other portion, I'm sure there's going to be some differences in degradation as well.
Thank you very much, sir.
Thank you. So the